Good afternoon, and thank you for coming along to CTD409 High Velocity DevOps. Hope you had a wonderful week so far here at reInvent and excited about all the new announcements and looking forward to the replay party tonight, right? Let's start off with a question. Imagine that you are starting today in your organization as a developer or a DevOps engineer. What does that process look like? You may start off with introducing to a few people, grant access to multiple different systems, including a Git repository. You may hand over your SSH, public SSH keys, push that into a repository or a secure store. And how many of you are happy about the time taken for a new engineer to get on board and them to add value to your organization? And if you think that this process can be improved, then you're at the right place. Because in today's session, we're going to go through some of the benefits that CI/CD, continuous integration and continuous delivery, will bring it to your organization, along with wider AWS platform offerings. My name is Shankar Pereira. I'm a solutions architect based in the UK. I'm with AWS a bit longer than 2 years now, but before joining AWS, I was a customer for a good 5 years. I'm here with my colleague, Ajar Ekak, senior engineer from CloudFront team. We also have great customer speaker, Gaurav Tiwari, who's a principal engineer from Realtor.com, here to share their story in migrating their application to Amazon CloudFront and wider Edge platform. So let's have a quick look at agenda. So we got a lot to cover during our presentation time. We will be available to answer questions after the session. All the presentations will be available online in both SlideShare and in YouTube. And feel free to contact us or contact our support team if you got further questions related to the topic that we are covering today. We start off with an introduction, going through simple steps that we all follow when developing and delivering applications, which is build, test, release, and monitor, right? Our main focus today is to give you information about how Edge services can be part of your software delivery lifecycle, what services are available to support you, and show you what Amazon uses when delivering applications in rapid pace. After that, Ajar will dive deep into build, test, and release, showing an example that we have built for our session and to reInvent. Then we'll go through some monitoring aspects to provide that intelligent monitoring and alerting and reporting capabilities. And at last but not least, Realtor.com's going to share their story, go through some key learnings and takeaways from their experience in migrating their applications to Amazon CloudFront and our other Edge platform. So this is a 400-level session, and I guess by now, most of you are familiar with DevOps methodologies. So I'm not going to get into a philosophical conversation about defining DevOps. But in simple terms, DevOps is dev and ops professionals working together collaboratively to improve your application development and delivery, right? Our main focus today is to show you how AWS can help you to get your DevOps strategy, not to stop at your origin, but to drive it all the way to the edge using our Edge portfolio. And in your DevOps practice, there aren't any silos. People take responsibility and they share responsibility by taking ownership. And if you wrote the code, it's easier to you to fix it at 2 o'clock in the morning than anyone else in the world. You may ask, who carries the pager? Or who does the QA? To answer to that is the two pizza team. Raise your hand if you're already familiar with Amazon two-pizza team culture. Okay, not many. So, back in 2001, Amazon was a big monolith. And over the years, we managed to break that monolith into simple microservices. And simple, small teams were responsible in managing these microservices. So we defined this, how small the team are, by if you manage to feed the team with 2 pizzas, it's a good small team. I strongly believe that it's crucial to maintain a small team structure to build a high-velocity DevOps team. So because our talk is about getting your DevOps strategy to the edge, let's have a look at what our edge portfolio consists of. Our edge service consists of CloudFront caching service. By the way, it's the CloudFront 10th anniversary. We released a blog post. Feel free to read that. And we are expanding our edge portfolio quite rapidly. I remember we released that by end of October, we said that we had 100 caching servers across the globe. And now we got around 150 caching servers. So you can see our rapid growth and our commitment to expand our platform. In addition to adding new edge nodes into our platform, which we call POPs, point of presence, we also expand in the existing capacity. By using CloudFront, you would be able to improve the performance of your application, improve the security posture. CloudFront is also, as many other AWS services, a pay-as-you-go model. So it provides better economy of scale. Edge is also consists of Amazon Route 53, which is our global DNS service, AWS WAF, Web Application Firewall service, AWS Shield and Shield Advanced, and AWS Lambda and Lambda at the Edge, which is the serverless compute at the edge. I'm sure by now, most of you are familiar with what a Lambda function is. Is that right? Everyone knows what a Lambda function is? Yeah. So let's have a quick recap. Let's have a quick look at a use case. Imagine that you are an engineer responsible in managing a large media website, and you want to improve and accelerate that media asset delivery. Depends on the browser type. You want to provide the right image type, whether it's a WebP or PNG. Depends on the device that people are browsing your site. You want to provide the right crop size or resize value, or you want to simply add a watermark to your images. It doesn't matter whether it's a single image or 100,000 images. Because Lambda is a serverless compute, you don't have to think about complex topics like DR, high availability, reliability, performance. If you can code it, you can run it as a Lambda function. So it's a great way for engineers and builders to adopt the serverless compute. Lambda is an event-driven architecture. That means it only executes when there's work to be done. So you don't pay for idle capacity. That works really well with the CI/CD pipeline when you have to manage multiple environments. That's great. But today, people expect things to happen instantly. They are very impatient. Who want to wait for page load times anyway, right? If there's page load time involved in your application or your website, people go elsewhere. Regardless whether they are traveling, accessing the site from poor mobile connection, or wherever they are in the world, people expect highly performant online experience. That's one of the things that Lambda at the Edge can bring it to you. Because with Lambda function attached to CloudFront distribution means you can execute the function a lot closer to your users. When we talk about CloudFront, CDN, as the name suggests, we talk about distributing content across the globe. But now with Lambda at the Edge, along with your content, you have the compute power at the edge. That allows customers to move many use cases to the edge, which wasn't possible before. When Amazon was a big monolith, getting the features that matters to our customers took way longer than what is needed to be. So Amazon is a very data-driven organization, and we looked at why is it taking so long? It's not the time taken to write the code, but rather it's the waiting time involved in every step in the way. So along with building microservices, building small teams, we also build lots of tools. I will now invite my colleague Eja to go through the CI/CD journey with you, show you how you can use the tools that we built to help you to automate software delivery process, how to improve that developer productivity, how to fix the bugs quickly, and most importantly, getting that features that matters to your business faster to your production. Thank you.
Thank you, Chanka. Hi, my name is Ajar. I'm a software developer with CloudFront for the last 5 years. In AWS, our aim is to give full control to the developer. This enables better availability, better security, and also faster delivery of the features. AWS provides many different tools to the developers so that you will control the destiny of your application. But how does CloudFront fit in this picture? Historically, CloudFront customers used to have a set up once and never touch approach. But recently, especially after the release of Lambda Edge in 2017, we are hearing more and more from our customers that they want to integrate CloudFront with their application stack. And they want to apply all the best practices they are already using with the rest of their stack with CloudFront and Lambda Edge as well. Today, I'm going to walk through an example which is created by CodeStar to show how we can achieve a continuous deployment pipeline with CloudFront and Lambda Edge. Let's take a quick look at what is CodeStar. CodeStar is a wrapper service around other AWS services. Basically, it gives you two benefits. The first benefit is that it gives you templates which are running out of the box so that you can directly dive into the code. And the second benefit is that it gives you a single UI which combines all the services that you use, all the builder services that you use in your application. For the purposes of the session, I started with a built-in template, which is a Node.js web application template. CodeStar creates multiple CloudFormation templates in order to create and manage the resources for you. Namely, these are a code commit repository for you to keep your code, but no worries, you can also use your existing GitHub account. Cloud9 environment so that you can edit your code, but still you can use your favorite integrated development environment. Code build for us to build the Lambda code, and the pipeline to integrate and coordinate the deployments. When you click on create, you will see that it will trigger the pipeline automatically. And when the deployment is done, it will run out of the box. This is super convenient. So as a reference, let me share what this template does. Basically, it creates an API gateway to handle the HTTP requests. And there's a Lambda function which actually serves the content. And our static objects are kept in S3. And this is the end state that we want to reach. So for the purposes of this session, we have two intents. Imagine that our company is working on a new version of our UI. We are in beta phase, but we want to test our new interface with our customers. But our new interface is not really ready to be the default interface. So we want to give our customers a way to see the new interface if they want to, and we will achieve it with Lambda Edge. I will talk about this later. And our second intent is using CloudFront. We want to use CloudFront to reduce costs in API gateway, S3, and Lambda. And also, we want to provide better latency for our global customers. I want to remind you that for the purpose of this session, I really will not spend much time on the backend code, and I will just focus on CloudFront and Lambda Edge pieces and how we deploy those. So let's do a recap on how Lambda Edge works. Basically, Lambda Edge provides 4 different event types for your Lambda functions in the lifetime of a CloudFront request. The first event type is viewer request event type. Viewer request is triggered before your request hits the CloudFront cache. Example use cases for viewer request are authentication at the edge or bot detection. The second event type is origin request. You can use origin request events for 2 different purposes. The first purpose is you can customize the request which is going to your origin, and example use cases for this are content-based routing. And the second purpose you can achieve with origin request is to generate responses right at the edge so that you can have originless CloudFront applications. The third event type is origin response events. With origin response events, you can manipulate the response that is coming from your origin before CloudFront caches it. One example use case is stripping origin headers. And the final event type is viewer response event type. You can customize the response to your viewers based on request parameters, and also you can trigger side effects such as download receipts to get reports of how many downloads happened right from the edge caches. Before diving into the code, I want to remind you again, we are going to share these slides over SlideShare. So don't worry if you cannot read all the code. I will emphasize on the important pieces. So we are using SAM template to create our Lambda Edge code. So what is SAM? SAM is an extension to CloudFormation. What it provides is convenience management of the serverless functions. Here, we are using auto-publish alias property of the serverless function, which will create a version each time there is a new code. This is required in our example use case because CloudFront requires Lambda function versions. And here, we are accepting a parameter stage so that we can reuse the same template for different stages of our pipeline. Namely, we can have a beta Lambda Edge function, we can have a gamma, we can have a prod. Let's take a look at the Lambda Edge code. So we are using origin request event for this example because in this example, our content is highly cacheable, and using origin request will reduce my cost because it will only be triggered when the object is not cached at the edge. So basically, this function inspects the query strings, and if the value matches, it shows a different content by changing the URI parameter of the request that is going to your origin. This is just a simple example, but you can use many different things as well. You can use headers, you can use cookies, you can use the device type, or many other different properties of the request as well in order to achieve this. So here are our templates of the CloudFormation template. Sorry, parameters of the CloudFormation template. I already talked about the stage, and the second important parameter is alias name. So we are going to use this alias name in CloudFront so that each stage of the CloudFront will be addressable with a different domain name. And this is the CloudFront resource of our template. Here, you can see how we refer to the alias name that we injected through the parameters. And here, you can see how we refer to the version that is being generated by the serverless function. So now our template is ready. We need to write the build logic to generate this generate this Lambda function. So CodeStar creates a code build project and the build spec file with it. And this build spec file is run by the code build project to upload your code to S3 so that you can deploy this function through CloudFormation. So what we are doing is we are adding one more line for Lambda Edge code. Remember that our backend code is also on Lambda, so it will be very similar to it. And also don't forget to export your process template because we need to access this template from our pipeline. This is the pipeline we are trying to achieve. So when there's a code change in our repository, it will trigger automatically. It will build the code, and then it will deploy CloudFront and Lambda at the edge. In order to achieve this, we need to do two changes in our existing resources, which is auto-generated by CodeStar. The first thing is we need to extend our pipeline, and the second thing is we need to extend the permissions of the roles that is generated by the CodeStar. You can make these changes through AWS console, but I strongly recommend that we use CloudFormation so that there won't be any drift our CloudFormation stack. Here, you can see the permissions for the pipeline role. So these permissions are required because like each resource, each CloudFormation template will be a different stack in this whole application stack. So here, for simplicity, I'm using the project name as a prefix. And the second permission you need to add is the permission for the CloudFormation role to really create this Lambda function and CloudFormation distribution. Sorry, CloudFront distribution. Okay, now our permissions are ready. We are ready to extend the pipeline. The first action we are adding is the generate change set. Here you can see how we inject our different parameters for this specific stage, which is our gamma stage. So we are injecting the stage name and also the domain name that we give to our gamma stage. And the second action is the step which actually executes this change set we created in the previous action. So after these changes has been deployed with CloudFormation, or maybe if you use console with console, it will not trigger a build because like CloudFormation code is not in our repository. So we need to click on release changes in the pipeline so that a new build will be triggered, so deployment will happen. And then you'll see it in action. Okay, now we've deployed in Gamma. We are ready to test our code. The first step of testing is unit testing. Lambda Edge supports Node.js, so you can use the framework that you are familiar with, Lambda Edge as well. This is obvious, so I'm not going to spend much time on this slide. A more interesting piece is how we are doing the integration testing. With continuous deployment, it's really essential that we are doing the integration testing integrated with our pipeline so that we can prevent the buggy code reaching out to prod. In our example case, I'm using the, again, JavaScript code with Mocha framework. But since this code runs with code build, you can use whatever language you want, whatever language you are familiar with. The second thing is that I understand that every organization have their best practices, but for the purposes of this example, I put my integration testing code in the same repository so that when I change the integration testing code, it will trigger a build. So I decided to use code build to do my integration testing. And with the code build, I don't want to run the existing build logic, so that I created a custom build spec file. And since I want to use this build specification for different stages, namely Gamma and prod, I am injecting the URL to test as an environment variable. So it requires me to create multiple different code build projects for each stage so that I can inject different values. Here you can see the CloudFormation template code to create these code build projects. Here you can see how we inject the environment variables. And this is our custom build spec code. Here we are not building anything. We are just running our integration testing. And then we need to add these code build steps into our pipeline. And when we deploy this CloudFormation, we need to click release changes again to see it in action. Now we are done with our integration testing. We are ready to deploy our code to prod. This is the end state we are trying to achieve with the release phase. So since we did a good job on reusing our templates for different stages, deploying to prod will be similar to deploying to gamma. Only the injected values will be different. So I'm not repeating the same steps for production as well. Okay, now we can see this in action. Okay, so this is our default homepage. And this is our beta page. It doesn't seem much different, but I didn't spend much time on the backend code. So here you can see that actually we are using the same URL, and the actual change of the content happens in Lambda Edge. Let's do a recap on what we did. We created a CodeStar project. We extended it with Lambda Edge and CloudFront. We added integration testing steps, and finally, we released to the production. Now, we need to operate this thing in production. My friend Chanka will help us how to operate this service.
Thank you, Ajay. So monitoring is the most important aspect of your applications, because if you can monitor it, you can improve it. So AWS provide out-of-the-box capabilities using CloudWatch. With CloudWatch, you can monitor, act, and analyze. CloudWatch provides metrics for CloudFront on requests, bytes downloaded, error rates, and you can extend some of the metrics using custom metrics, and you can integrate CloudWatch with third-party solutions on our marketplace. In addition to Lambda Edge and Lambda execution logs and distribution access logs, which developers already use to debug some of the errors, we now provide logs to figure out the integration errors between Lambda and the CloudFront, which helps to extend that troubleshooting capabilities and help you to figure out the issues with your Lambda functions quite quickly. And this is another example with AWS WAF and Shield, where CloudWatch provides metrics for Shield, it's DDoS detected, bytes per second, packet attacks per second, and with WAF, the requests, allowed requests, block requests, counter requests. And you can extend some of these metrics that you got and integrating with the third-party solutions like PagerDuty for alerting, or integrate with your Slack channels. Over my career, there's so many times that I've been asked to provide who has done what and when. I'm sure if you're coming from ops background, that questions might be familiar to you. And in traditional infrastructure, if you got SSH access or if you got access to the system, probably you SSH into multiple different systems and aggregate, and you would be able to provide that details. But in the cloud, and especially in microservices world, it is a lot more complex than that. So that's where CloudTrail comes into the place. With CloudTrail, enables you to provide that governance, compliance, report auditing, and risk auditing of your applications and services. Regardless, you access the site using the AWS console, command line tools, or practice infrastructure as a code using CloudFormation, CloudTrail would log that request. So by using CloudTrail, you can copy these CloudTrail logs into S3, and you can query using Athena to answer the questions from the data. This is a solution that I took it from a solution builder blog post that we released a few months ago, where it shows that CloudFront logs and other logs that you get from your application can be copied into S3, and you can use AWS Glue, which is our ETL product, to build a catalog. Or if the data is, when the data is in S3, you can use Athena to query data and ask the questions from the data. Or you can extend this data to provide some visibility dashboards using Amazon QuickSight or Tableau, any other kind of visualization and analytics tools that you have. Or you can use the data to do machine learning. And another example where you can extend some of the CloudWatch metrics and integrate with third-party solution. In this case, it's a Sumo Logic, which is showing you some of the dashboard metrics from AWS Shield and wider Edge services platform. I know that in reInvent, we also announced some new features for CloudWatch, and feel free to keep eye on our What's New page to get to know more about new features that we release in our monitoring space. I will now invite Gaurav to share the Realtor.com story with you. Thank you.
Thank you, Chanka. Hello everyone, I'm Gaurav Tiwari. I'm Principal Software Engineer at Realtor.com. Today I will share some of the key use cases for Lambda at the Edge and CloudFront for Realtor.com. I will also talk about what we have learned from these experiences so that you don't get your hands burned while trying out something similar. But before we begin, a little bit of history of who we are and a precursor to some of the use cases. Realtor.com is part of family of products designed to make all things home simple, efficient, and enjoyable. We offer the most comprehensive source of for sale properties among competing national sites. We also provide the information, tools, and professional expertise to help people move confidently through every step of their home journey. Realtor.com is also a key part of News Corp family of businesses. This relationship has placed us firmly in the largest global digital real estate network. More than 20 years ago, Realtor.com has pioneered the world of digital real estate. It is not unusual for the company of this age to have a few legacy systems and technical debt. We compete in highly aggressive marketplace, and to remain competitive, we needed to put customer first, iterate on their feedback, improve our velocity, and have quality improvements to our products and services. In 2014, News Corp acquired Realtor.com. In 2015, we began to completely execute our plan to transform how we build, produce, deliver, and support our products and services. We embrace the culture, process, and technology of DevOps, Agile, and public cloud. While we were on this journey, initially we were completely on data centers. Around that time, News Corp announced a goal to be 75% compute in public cloud. We asked ourselves why stop there and set up our self-target to be 100% compute in public cloud. On this journey to migrate from data center to AWS, we wanted to follow certain guiding principles. Keep things simple, design services, and use AWS platform. In nearly first 6 months on this transition, we moved our front-end infrastructure to AWS. To make this possible, our dev team took the initial lead and ensured that ops team is on board. Together, they set up initial Jenkins deployments for continuous integration and continuous delivery. We used CloudFormation templates to version our infrastructure. This was really important, which helped us to create identical to production-like environments, our sandboxes were very identical to production, so that no one can say, hey, this works on my system and it breaks in production. So with this precursor, I would like to talk about some of our key use cases for Lambda at the Edge and Amazon CloudFront. We make data-driven decisions. So we do a lot of A/B tests. How many of you are aware of A/B test terminology? Raise your hand. So there are a few. So the people who are not aware of this terminology, A/B test in the context of web applications is a method to test multiple versions of website and compare them against each other. The comparison could be based on certain metrics, such as conversion, it could be unique users, number of pages, and others. So almost a year later, there was a requirement to set up custom A/B test framework for the brand new version of our website, such that the dev team control the entire logic, configuration, and deployments for the solution. Some of the other key requirements for this solution were we should have ability to tag user from the very first request for a specific micro markets and show them brand new version of our website. We also need to have ability to show variation from multiple applications. I'm not talking about single application, these are multiple applications. For this entire new solution, the latency should be less than 30 milliseconds. And since we were building this solution from scratch, as expected, this should be completely unit testable, and deployment should be pretty straightforward because dev team wanted to build continuously on this one. So we looked at multiple solutions and found Lambda at the Edge and Amazon CloudFront sitting very nicely for these requirements. During our POC phase, we found that we are able to make use of user viewer origin request at Lambda at the Edge to route request to multiple applications. We were able to make use of Lambda at the Edge to read cookies and make decision for the user and tag user to a specific version of the site that we want. For this solution, we perf tested and found that the latency is well within the limit. Since this is again another Lambda function, as Ajar and Chanka mentioned, this was written in JavaScript and completely unit testable. Our DevOps team set up Jenkins deployments for us, so the deployments became very smooth for Lambda at the Edge and CloudFront updates. With the success of this A/B testing framework, we pushed it to production. And I would like to talk about this architecture in a bit. So when the user makes a request, there is content switch gateway on the left side you see on the screen. There are about 70 rules. I will talk about this in a few slides in detail. Then the request actually directly goes to the application version 1, let's say, if Lambda at Edge and CloudFront are not sitting in between. Once we have Lambda at the Edge and at CloudFront, we are now able to route the request to multiple versions of the application by reading dynamic configuration from DynamoDB at runtime and making those decisions based on the user information, cookies, and others. So with the success of this A/B testing framework in production, we realized the true potential and what we can achieve with Lambda at Edge and CloudFront. In the parallel stream of work, our ops team were running into some challenges with the content switch gateway I just mentioned. Some of the key challenges that they were facing were there were more than 70 rules, and each rule has multiple sub-rules. So anytime they wanted to make any change to those rules, they have to be very careful because we did not have good monitoring for those rules. The entire testing effort for this was completely manual, and due to manual testing effort, the overall deployment time was really, really high. So we were very limited in deployments. We were making 1 to 2 times deployments a week. And above all, this was like a fixed pricing model versus everything else in the previous architecture you have seen is on AWS, which is pay-as-you-go pricing model. So again, we took a cue from our previous solution that we did for A/B testing framework and found that Lambda at the Edge and CloudFront can again solve this problem. For this solution, we set up Jenkins pipeline this time. So instead of making manual changes, our ops team now become part of DevOps team, and they are making code commits via GitHub Enterprise to check in their changes. Once they go through the regular PR, review, and merge process, after merge, it triggers a build, which run the test cases and deploy the changes to Lambda at the Edge and CloudFront. We versioned our configuration with GitHub Enterprise and versioned the infrastructure with CloudFront CloudFormation templates. We also used AWS X-Ray, CloudWatch, and New Relic for monitoring. As Chanka just mentioned, that if you are not monitoring and you are not measuring the metrics, you will not be able to improve. So this step was really important for us. So in this architecture diagram, if you recall the previous one, we had previously content switch gateway, which has web access firewall rules. So we moved the WAF rule inside AWS WAF, and we moved the content switch gateway rules, more than 70 rules, to Lambda at the Edge. Now with every request, these rules are running inside the Lambda function, completely testable solution. And once the rules are parsed and executed, we are now executing our Lambda at the Edge A/B test cases, where we are able to route requests to application A, B, and C. With good monitoring, I think I mentioned earlier about New Relic, AWS CloudWatch, and X-Ray. We also enabled our access log to log on to S3 bucket as well, so that later we can run Athena query if we want to slice and dice information further. So the impact of this overall solution, we moved from manual changes to completely automated pipeline. The check-in, after check-in, when the PR gets merged, once the PR is merged, to the deployment time, it was completely 15 minutes time. I'll share some of the metrics in a bit. This complete automation brought the DevOps team completely in control. Now the ops team, their role did not become obsolete. They are rather happy to be part of DevOps team and more confident while making their changes, because one, there are multiple eyes on this while during the PR review process, and two, we have good automated test coverage. So some of these slides, I would like to share the metrics and our Jenkins pipeline here. So this is our typical Jenkins pipeline we have for the solution. We are in the pre-deployment setup. We are running our test cases. Once test cases are passing, it goes on to deploy to Lambda at the Edge and then CloudFront. To have better visibility in monitoring and logging, we used CloudWatch metrics to see Lambda invocation and errors. We also kept an eye on average execution time of Lambda function and keeping an eye on throttling, since this is just another Lambda function. And with Lambda throttling, we need to be really careful. If anytime we see throttling, it can increase the overall execution time of Lambda function and requests. We kept an eye on long tail of execution time with X-ray and debugging. We use New Relic metrics to see which rules are becoming obsolete. Now we have better monitoring in that. New Relic monitoring also helped us to analyze our error patterns too. So the result of this entire exercise and after these two projects, we have better monitoring and in-depth monitoring for our solution. We have good automation completed. We have average latency still well within the limit, less than 20 milliseconds. And with the automation, velocity has improved immensely. We are doing multiple deployments a week now. So just doing a recap and thinking about what we have seen so far. We have seen 2 use cases for Lambda at the edge and CloudFront for A/B testing, as well as we moved our content switch gateway, which were some custom rules inside Lambda function. I would like to share some of the lessons we have learned along this journey. Testing is really important. We turned on the WAF rule and count mode and then optimized them later versus the other way around, to ensure that performance is not degrading while we are moving our content switch gateway inside Lambda function. We took percentage of requests from production traffic and replayed on production-like environment multiple times to see the performance is still up to the mark, which also ensured that we are not running into errors while we moved our content switch rules here. The complete automation with Jenkins pipeline improved our velocity. Also, with the dev and ops team working together, it improved our agility from the solution 1 where we did custom A/B test setup to the solution 2 where we did a migration of content switch gateway rules. The second time we did the similar thing, it took really less time for us. In this solution, we did not have manual changes now. Things are going with a proper process and automation, which brought more robustness and more confidence in our solution. There are plenty of tools available for monitoring. We found CloudWatch metrics and X-ray rules are really useful for us. So find what better tools are available for you and what are best suitable for your applications. Also, I think I mentioned this earlier, but reiterating that keeping an eye on Lambda function is really important, Lambda throttling. CloudWatch metrics are the ones which are really helpful for this. Above all, collaboration is the key to DevOps success. Nothing happens in vacuum. This work would not have been possible without the work of impassioned developers and system engineers working across the entire organization. Also, we found able partner with AWS technical account managers and support team who worked very closely with our DevOps team and made some very tricky things simple for us. So what is next? We have some new exciting challenges coming in for us. We have image resizing at runtime with CloudFront and Lambda at the edge coming up for us. After Realtor.com, we have Moving.com already on this solution, and there are a bunch of other domains already lined up to migrate. We have Lambda blue-green deployment and ECS blue-green deployment already work in progress. If you would like to know more about the solution we talked about, or if you have some questions, I'm happy to answer some of your questions after this session. If you would like to work on some of these exciting challenges, come join us. Thank you.
Thank you, Gaurav. So let's have a quick look at some of the key takeaways that we can take home from our session today. So I would encourage everyone to consider our Edge portfolio as part of your application delivery lifecycle. I remember when I was an engineer and a customer, we deploy our application into Origin, and then we hand it over to the ops team to configure the Edge CloudFront configurations. But with our stack, you can access using the console to start with, use command line tools, and use infrastructure as a code using CloudFormation. And as we showed in our session, you can automate of your build, release, and test process. Use the monitoring capabilities with CloudWatch, extend that with CloudTrail, use the example pipelines that we showed in our blog posts to get the maximum out of the data that you have within your platform. And most importantly, every day when you wake up in the morning, if you keep an eye out of our What's New page and the Jeff Barr's blog, there's new features being added to our platform on a daily basis. And feel free to have a look at the new features that we added into our platform of the services that we have discussed today in our session, and also the new services that we have released in this reinvent. Thank you for coming along, and please use the app to give us the rating and give us the feedback, because your feedback is very important to us to improve and run more sessions like this and to improve our sessions in the next reinvent. Thank you.